Today, I'll be checking a hot glue gun that hasn't been used for a long time. First, I plug it into a power outlet to supply electricity to the device. As you can see, I've pressed the power switch several times, but the indicator light on the glue gun still doesn't turn on. This suggests that the device may have a problem and is no longer working properly. However, instead of throwing this glue gun away, today I'll try to repurpose it and turn it into a simple soldering tool. First, I use a screwdriver to remove the screws from the body of the glue gun, then separate the outer casing to inspect the components inside. This video is for educational purposes only and is intended for DIY enthusiasts. Projects involving soldering, electricity, and mechanical tools can involve potential risks. Always wear appropriate protective equipment, follow proper safety procedures, and use tools correctly. Do not attempt any dangerous procedures if you do not have the necessary knowledge or experience. After opening the outer casing of the hot glue gun, I'll remove the internal components because they are no longer usable. I'll keep only the outer casing and repurpose it as the frame for the soldering tool. First, I'll use a tire valve and 2 washers to make the soldering tip assembly. I attach the first washer to the tire valve and then install this assembly at the front of the device. Next, I place the second washer on the outside and tighten the nut to secure the assembly firmly in place. In the next step, I prepare a piece of electrical wire to serve as the power lead for the soldering tool. First, I strip the insulation from the end of the wire to expose the copper core. I do the same with the other end of the wire, then twist and separate the exposed copper strands into 2 separate groups, preparing them for the next connection step. Next, I use a short piece of copper wire as a temporary connector for the electrical wire. I twist one end of the electrical wire together with the end of the copper wire. This copper wire makes it easier to guide the electrical wire through the hole in the tire valve and into the inside of the device casing. Then, I feed the copper wire through the tire valve to pull the electrical wire through the casing. I adjust the wire so that the other end is positioned correctly inside the tire valve. Once the wire has been pulled through completely, I cut the connection between the electrical wire and the copper wire. In the next step, I prepare 2 metal washers and an alligator clip to make the connection points for the wires. First, I twist one end of the soldering tool's wire around a metal washer to create a secure contact point. At this point, the basic frame of the soldering tool is complete. Next, I prepare another blue electrical wire to serve as an additional connection wire. I strip the insulation from the end of the wire to expose the copper core. Then, I attach an alligator clip to the end of the wire. The alligator clip provides a quick, secure connection that can be easily attached and removed when checking or changing the connection. Next, I attach a metal washer to the other end of the wire to complete the connection points of the device. Next, I will repurpose an old battery to make the soldering tip for the device. First, I use pliers to remove the outer metal casing of the battery. Next, I use needle nose pliers to grip the carbon core inside and slowly twist it to remove the core from the casing. After that, I use a paper towel to clean the outside of the carbon core, removing any dirt and residue left on its surface. In the next step, I attach the carbon core to a drill to prepare it for shaping. I turn on the drill and bring the tip of the carbon core into contact with the sandpaper to grind and shape the end. Grinding the tip helps create a smaller and more compact contact point, making it better suited to the design of the soldering tip and allowing it to make contact with the area being heated more easily. After finishing the soldering tip, I attach it to the front of the soldering device. Finally, I put the components back in place and tighten the screws to close the outer casing securely. Next, I connect the ground wire to the negative terminal of one battery. Then, I connect the electrical wire from the soldering device to the positive terminal of the other battery to prepare for testing. As soon as the soldering tip of the device makes contact with the connection point, a spark immediately appears. This shows that the device is producing electrical current and heat, allowing me to move on to the next tests. For the first test, I will check the device's ability to join two electrical wires. I prepare two pieces of wire and create a connection between them. After completing the connection, I check its strength by gently pulling on both ends of the wires. The result shows that the two wires remain securely connected and the joint does not separate easily. For the next test, I will check its ability to join two thin pieces of metal. After completing the joining process, the two metal pieces are held together. I then check the strength of the joint to see whether it can keep both pieces of metal securely in place. For the final test, I will repair the broken handle of a metal cup. First, I prepare a small piece of metal to reinforce the damaged area. Then, I place the metal piece over the broken section of the handle and secure the two parts together. After completing the reinforcement, I check the handle again. The result shows that the handle has been secured back into position, and the joint remains fairly strong when lightly tested. If you enjoyed this project, don't forget to like, subscribe, and turn on the notification bell so you never miss my next DIY videos. Thank you for watching. I'll see you again in the next video.